Hello friends, today we will go through irrigation engineering, and in this video we will mainly focus on the different methods of irrigation. So watch the complete video. Irrigation may be defined as the science of artificial application of water to the land in accordance with the crop requirement throughout the crop period for full nourishment of the crops. There are different methods of applying water to the irrigating field. So, before going through the different methods of irrigation, we need to know the system of irrigation first. So, the system of irrigation can be broadly classified into two types, as first is your lift irrigation and second is your flow irrigation system. Here, furthermore, the flow irrigation system is classified into two bases. First is your inundation or flood irrigation system. Second is your perennial irrigation system. Furthermore, the perennial irrigation system can be classified into two types, as first is your direct irrigation, second is your indirect irrigation or storage irrigation system. Now, first we will go through lift irrigation system. When water is lifted from surface sources or underground sources by man or animal power, mechanical or electrical power, and directly supplied to the agricultural land, then it is known as lift irrigation. In this method, isolated small area can be irrigated. The vast area cannot be irrigated by this system. The various advantages of lift irrigation systems are: farmers can apply water to their field according to the requirements, and hence there is no possibility of over irrigation. Likewise, the water table is lowered when the water is lifted from the well, thereby reducing chances of waterlogging. Similarly, as the water is supplied directly to the fields, there is no water loss due to convenience. Moreover, the initial cost is low, as there is no necessity of constructing hydraulic structures. Likewise, as the loss of water is low, the duty of water is high. Similarly, the maintenance cost is very low. Likewise, more than one crop can be grown in a year on the same land. Furthermore, loss of valuable land is prevented, as there is no necessity of construction of networks of canal. Some of the few disadvantages of lift irrigation system are: if the lifting mechanism, that is pump, fails due to mechanical or electrical failure, then the water cannot be supplied until the mechanism is restored. Likewise, the well water has no silt content. The yield of a crop therefore depends on the chemical fertilizers, which is a bit costlier. Similarly, the lift irrigation, in consideration with the yield of crop, is not cost effective. In Nepal, Nairani lift irrigation, Machhawar lift irrigation, Waling lift irrigation are some of the few examples of lift irrigation projects. Now, second is our flow irrigation system, and in this system, water flows under gravitational pull through the artificial canal towards the agricultural land. And in this system, the head of the canal should always be at higher elevation than the land to be irrigated. The following are the different systems of flow irrigation. First is our inundation irrigation system, or also known as flood irrigation system. And in this system, a canal is excavated from the bank of the inundation river. That is, the river which flows in rainy season only, and that is nearly dried up in summer and winter season. And in this type of irrigation system, there is no regulator at the head of the canal for controlling the flow of water. Likewise, the bed level of the canal is fixed at such level that the water can flow through the canal only when water level of the river raise above the canal bed. So, this system of irrigation depends completely on the water level of the river. Now, second is our perennial system of irrigation, in which a weir or barrage is constructed across the perennial river to raise the water level on the upstream side of the dam. Here, the perennial system of irrigation can be further classified into two bases. First is our direct irrigation system. Second is our indirect or storage irrigation system. Now, this direct irrigation system is a system in which a weir is generally constructed across a perennial river to raise the water level on the upstream side up to a certain extent, so that the water can flow through the canal. Here, the water level on the upstream side will remain at a constant height and excess water flows over the weir. Sometimes a barrage is constructed in the replacement of the weir to regulate the water level on the upstream side. The hydraulic structure which is constructed in direct irrigation system is also known as diversion headwork. Now, second is our storage irrigation system or indirect irrigation system, in which a dam is constructed across a river for a storage reservoir. The main canals may be taken from both sides of the dam. The flow of water through the canal is controlled by head regulators. These storage reservoirs can be used for various multi-purpose actions, and it can serve various purposes like for irrigations, water supplies, hydroelectric power, flood control, fisheries, etc. Now, after going through the different system of irrigation, we will now proceed into the different methods of irrigations. Now, the different methods of irrigation can be classified as: first is our surface irrigation method, second is our subsurface irrigation method, third is our sprinkle irrigation, and at last, fourth is our drip or trickling irrigation method. Here the method of irrigations are classified into four topics, as first is our surface irrigation, second is our subsurface irrigation, third is our sprinkle irrigation, and fourth is our drip irrigation. Here the surface irrigation system method is further classified into three types, as first is our flooding irrigation, second is our controlled farming, third is our furrow irrigation. Here the flooding irrigations can be further classified into free flooding, border flooding, check flooding, basin flooding, and zigzag flooding. Likewise, the subsurface irrigation system is further classified into natural irrigation method. Second is our artificial irrigation method. First is our surface irrigation method, and it is the most common method of irrigation. In this method, the flow of water takes place over the surface of the earth, and since water is applied to the field in varied quantities and at different times, the flow in this type of method remains unsteady. Likewise, the method involves diverting a stream of water from the head of a field into furrows or borders and allowing it to flow downward. The advantages of surface irrigation method is that it allows use of machinery for preparation of land, cultivation and harvesting. Likewise, it helps to store the required amount of water in the capillary zone of the soil for supply to the root zone of the plant. The disadvantage is that there is greater loss of water by surface runoff and deep percolation, larger requirement of water per unit area. Likewise, water is lost in infiltration and deep percolation. Similarly, there is low efficiency due to imperfect control over the water flow. Furthermore, inferior quality crops with low yield may occur. Moreover, wasteful use of water compared to better irrigation method. So it may be costly and time consuming in relation with land preparation. Now, the surface irrigation method is further classified into three methods. First is our flooding method, second is our contour farming, third is our furrow irrigation method. Here, first we will go through flooding method of surface irrigation system. In flooding irrigation, water is allowed to cover the surface of the land in a continuous sheet, the water standing just long enough in the field for the soil to absorb the water applied to refill the root zone. Now, this flooding system, that is flooding method, is further classified into two categories. First is our wild flooding, or also known as uncontrolled flooding, and second is our controlled flooding. So here we will first go through uncontrolled flooding. So uncontrolled flooding is the most primitive and most inefficient method of irrigation. In this method, water is sprayed over the smooth or flat field without much control over the flow or land preparation. The water is sprayed into the field from the ditch excavated either on the contour or up and down the slope. This method is applicable to inundation irrigation system or for pastures or forage crops where water is available in abundance and the highest elevation and is inexpensive, or the crop values do not justify adoption of better method. The water distribution is quite uneven. The method is suitable for all medium of fine texture soils. It has low cost and doesn't interfere with tillage. The disadvantages of this method are wasteful use of water, and there will be non-uniform distribution of water. Likewise, excessive soil erosion on steeper slopes that may require a good drainage facility. Now, second is our controlled flooding, and in controlled flooding we have different flooding techniques. So we have here 5 flooding techniques. First is our free flooding, second is our border or strip flooding, third is our check flooding, fourth is our basin flooding, and fifth is our zigzag flooding method. So here in controlled flooding, first we will move through free flooding. Now, the free flooding method is also called as ordinary flooding. It is the common adopted method where irrigation water is in huge amount and cheap. The land is divided into the plots of suitable size depending on the porosity of soil. Water is spread over the field from watercourse. The irrigation operation begins at the higher area and proceeds towards the lower area. The flow is stopped when the lower end of the field has received an desired depth of water. This method is mostly suitable for soils of medium texture and with moderate slopes. The second method of controlled flooding is border flooding method. In this method, the field is divided into narrow strips by low parallel ridges on the sides. The border strip is formed by leveling and grading the land between the ridges. The size of the strip depends on the type of soil, slope of the land, and size of irrigation stream. The width of the strip varies from 5 to 15 meters and length varies from 60 to 100 meters for sandy loam soils, 100 to 120 meters for medium loam, and 150 to 300 meters for clay loam and clay soils. The entire land, including the rounded border ridges, is utilized for cultivation. Thus, no land is lost to production. Water is let into each strip in a thin sheet through a set of outlet or siphon pipes, underground concrete pipes, through riser placed along the upper end of the border. Water flows down the slope along the length of the strip at non-erosive velocity, covering the entire width of the strip. Thus, sufficient moisture is provided to the soil profile to the entire length of the border. Even distribution of water is ensured if the strip is leveled at a more or less uniform longitudinal slope. The advantages of border irrigation is that it utilizes large water streams safely and it requires less labor and time. Likewise, the maintenance cost is very less. Similarly, it provides uniform weighting and efficient use of water. Likewise, there are few disadvantages of border irrigation as well. So first disadvantage is that it required proper labeling. Likewise, the initial cost is high and a large water supply is necessary. Now the third method of controlled flooding is check flooding, and it is widely practiced method of irrigation in the Tarai belt of Nepal. Furthermore, it consists of applying water to relatively level check basins enclosed by small bunds. The checks are square, rectangular, or irregular plots. If the ground has some initial slope, leaves may follow the contour. The size of check basin may range from 3 meter by 2 meter to 30 meter by 30 meter or even larger. In orchards, checks are used to irrigate each tree or a group of few trees in a check basin. The leaves are 2 to 3 meter wide at the base and 25 to 30 centimeter high in order to avoid obstruction to the movement of farm machinery, as also to permit growth of crops over them. This method is especially suited to fine textured soil which requires the holding of water in order to secure the desired penetration. Likewise, this method is suitable for growing grain and forage crops. Furthermore, the use is generally restricted to relatively smooth land because of the expenditures involved in leveling the plots. The advantage of check flooding is that high irrigation efficiency can be achieved with properly designed check system. Likewise, unskilled labor can be employed as there is no danger of erosion. Likewise, there are few disadvantages of check flooding as well. So some of the few disadvantages are high labor requirement is essential. Likewise, leaves impose restriction in the use of modern farm machinery. Similarly, use is generally restricted to relatively smooth lands because of the expenditures involved in the leveling the plots. Now, the fourth method of controlled flooding is basin flooding, and it is essentially a check method of flooding adapted for irrigation of orchards. In orchards, basins are made around one or more trees depending on the soil conditions and topography. For the efficient irrigation, each basin has to be labeled grade less than 0.1% with no cross slope. It is adapted especially to flat lands. Water is filled quickly in the basin and is allowed to percolate into the soil. It is desirable for close growing crops and orchards on medium to coarse textured soil. Now, fifth method of controlled flooding is our zigzag method of flooding, and it is a special method of flooding that is suitable for relatively level fields. But this method is unsuitable for mechanical farming operation. In this method, land is divided into square or rectangular plots. Each plot is further subdivided with the help of low bunds or leaves. Water enters at the upper end of the plot and follows route to reach the lower end of the plot when supply is cut off. The second method of surface irrigation is our contour farming, and it is adapted to hilly areas with steep slopes and quickly falling contours. The land is divided into longitudinal curved plots and bunds of the plot following the contour. The irrigation water is stored higher up in some depression shows between the bunds. The cultivation of crops is along the contour line instead of the usual down the slope. Contour cultivation reduces runoff and soil loss. The third method of surface irrigation is furrow irrigation method, and this method is commonly suitable for irrigating row crops. A furrow consists of a narrow ditch between the rows of crops. Water is applied in a small stream between rows of crops grown on ridges or in furrows. The characteristic feature of furrow irrigation is that, unlike flooding method, only half to 1/5 of the irrigated land surface is weighted, thereby cutting down the evaporation losses. Water flowing in the furrow seeps into the soil and spreads laterally to irrigate areas between the furrows. For distribution of water to furrows, the main ditch is placed in the higher side of the field. The size and shape of the furrow depends on the crop spacing, equipment used for the formation of furrow, and intercultivation. Long furrows are advantageous in intercultivation. However, too long furrow results in deep percolation losses and soil erosion near the upper end of the field and too little water near the tail. The advantages of furrow irrigation method is that there is low evaporation losses as only one half of the irrigated land surface is weighted. Likewise, it is possible to cultivate earlier in heavy soils. Furthermore, furrow serves as drainage ways for surface runoff in areas of heavy rainfall, especially suitable for crops like maize that are injured by contact with water. No wastage of land in field ditches. Similarly, fairly efficient in terms of water. Likewise, relatively cheap to construct and maintain, and there is the efficient use of water in furrow irrigation method. Likewise, there are few disadvantages of furrow irrigation method as well. So some of the few disadvantages are not recommended for very light soil having high infiltration capacity. Similarly, this may interfere with tillage, usually expensive from the consideration of time and labor cost. There may be serious erosion hazard, and adequate drainage need to be provided so that it may be sometimes costlier as well. We have dealt with the surface irrigation method. Now we will be focusing on the subsurface irrigation method. In subsurface irrigation method, water is applied beneath the ground by creation and maintaining an artificial water table at some depth, usually 30 to 75 cm below the ground surface. Moisture moves upward towards the land surface through capillary action to meet the requirement of the crops in plant roots. Water is applied through underground distribution system consisting of a properly designed main field ditches, laterals laid 5 to 30 meter apart. Subsurface irrigation requires little field preparation and labor. It entails minimum evaporation loss and surface waste. The use of subsurface irrigation is limited because it requires certain soil conditions. That is, the soil is permeable in root zone, underlined by an impervious horizon or high water table. For subsurface irrigation, the essential requirement is that field must be nearly level and smooth. And the topographical conditions are to be uniform. Likewise, the subsoil water table is within 2 to 3 meters below the ground surface, and availability of adequate outlet for drainage of the area is to be available so that irrigated particularly in the humid areas. Now, the subsurface irrigation can be classified in two categories. First is our natural subsurface irrigation, and second is our artificial subsurface irrigation. Now, in natural subsurface irrigation, is applicable to low-lying lands where water table is high and within the capillary reach of the root zone of the crops. Now the second classification of subsurface irrigation method is our artificial subsurface irrigation method, and it is very expensive method. Its use is indicated only under favorable water supply and subsoil condition for high yielding crops. The water is provided to crops by capillarity through a network of buried perforated pipes which carry water under pressure to percolate the soil. Now we will proceed to the advantages and disadvantages of subsurface irrigation method, and firstly we will go through the advantages sections. The advantages of subsurface irrigation method is that there is minimum water requirement for raising crops, and this method is suitable for most of the crops. Likewise, there is minimum evaporation and deep percolation losses, and the yielding of crop is high. This method is most economical compared to flooding method. Likewise, it involves no wastage of land and no interference in free movement of farm machinery. Cultivation operation can be carried out without concern for the irrigation period. Little field preparation and labor are required. Likewise, the disadvantage of this method is that there is the possibility of choking of the pipes laid underground, and there is a danger of development of waterlogging as well. Now the third method of irrigation is sprinkle irrigation method. And it is an improvement over conventional surface irrigation method. It simulates natural rainfall to spread water in the form of rain uniformly over the land surface just when needed, and as much needed at a uniform pattern and at a rate less than the infiltration rate of the soil, so as to avoid surface runoff from irrigation. Sprinkle is a versatile means of applying water to any crop except field crops such as paddy, soil and topographic condition. It is particularly useful in areas where there is shortage of water and in the hill slopes and are steep and can erode with other method of water application. Surface ditches and prior land preparations are not necessary for sprinkle irrigation. Also, the flexible pipes and fittings can be transported to remote areas easily. Sprinkling is suitable for sandy soils or any other soils and topographic conditions where surface irrigation is insufficient or expansive, or where erosion of soil may be particularly hazardous. Low rate and amounts of water may be applied, such as are required for seed germination, frost penetration, delay of fruit budding, and cooling of crops in hot weather. Fertilizer and soil amending chemicals may be dissolved in the water and applied through the irrigation system. Now the various advantages of sprinkle irrigation system is that it provides protection to small plants from wind damage and soil from blowing. Likewise, it provides protection against freezing injury to crops, and it is the most successful against radiation frost. Likewise, sprinkle can control the soil temperature during period of high incoming radiation. Soil temperature can rise up to 20 degrees Celsius above the ambient air temperature. Some of the few disadvantages of sprinkle irrigation is that pressure head and sediment free water is required, so not suitable at plain land. Likewise, initial cost is relatively high and regular operation is required due to frequently clogging of system. Similarly, it doesn't suit for paddy crop. Likewise, high air flowing area is affected during the operation. Furthermore, due to circular spraying of water, there is chances of over irrigation and no irrigation at some area. Finally, fourth is our drip irrigation or trickle irrigation method, and it is a method of applying water directly to plant through a number of low flow rate outlet called emitter or drippers, generally placed at short interval along small tubings. One of the main characteristics of this method is point irrigation as compared to area irrigation with sprinkle or flood irrigation. A network of lateral with deeper supply the water and fertilizer to the plant roots. Water is generally discharged at very low rate in order of 1 to 2 liters per hour, although high rate up to 8 liters per hour or more can be achieved using special drippers. This type of irrigations can be applied for the arid regions for fruits and nut trees, grapes and other crops, sugarcane, pineapple, strawberries, flowers and vegetables. Some of the few advantages of this method is that only the root zone of the plant is supplied with water. With proper system management, deep percolation losses can be minimized. Likewise, the evaporation losses are minimized because only a portion of the ground area is wetted. Furthermore, effective weed control, especially for ground area that is not wetted. Likewise, reduce percolations and evaporation losses, resulting in greater economy of water use. Furthermore, fertilizer and nutrient loss is minimized due to localized application and reduced leaching. The water application efficiency is high if managed correctly. Furthermore, the field leveling is not required in drip irrigation method. In addition to that, fields with irregular shapes are easily accommodated and the moisture within the root zone can be minimized at field capacity. Furthermore, soil erosion is lessened and weed growth is lessened as well. The water distribution is highly uniform, controlled by output of each nozzle. The labor cost is less than other methods of irrigation, and variation in supply can be regulated by regulating the valves and drippers, usually operated at lower pressure than other types of pressurized irrigation, reducing the energy cost. There are few disadvantages of this irrigation system as well. So, some of the few disadvantages of drip irrigation system are that the frequent clogging of dripper can occur, and for that constant supervision is required. This type of irrigation may not be suitable to some crops as salinity can develop as salt tend to accumulate along the fringes of the wetted surface strip. Likewise, root development may be restricted to the wetted soil volume near each emitter. Likewise, not suitable for very closely seeded crops such as carrot, radishes. Furthermore, initial cost can be more than overhead system. Likewise, the sun can affect the tubes used for drip irrigation, shortening their usable life. Likewise, drip irrigation system cannot be used for damage control by night frost. The other disadvantages of drip irrigation is that in lighter soils, subsurface drip may be unable to wet the soil surface for germination. It requires careful consideration of the installation depth, and furthermore, waste of water, time and harvest also occurs if not installed properly. These systems require careful study of all the relevant factors like the topography of land, soil, water, crop and agroclimatic conditions, and suitability of drip irrigation system and its components.
So friends, if you find this video as useful, you can like and share to your friends. And for such videos, stay tuned to this channel. Thank you. We will meet soon in another video.